Hi guys, welcome to the rundown of today's calculation. It is Kc calculation where we know the value of Kc and we have to work backwards to figure out our concentrations. So this is what the question might read like. It says the value of Kc for the reaction H2 plus I2 to give me 2Hi is 50 at 450 degrees Celsius. We have to calculate the final concentration of each species if 1 mole of H2 and 1 mole of I2 come to equilibrium at 450 degrees Celsius in one flask. So the first thing I'm going to do is rewrite out my equation, and all I'm going to do is write down my initial. So initially it tells me I have 1 mole of hydrogen and I have 1 mole of iodine. At the very beginning, at the start of the reaction, we have none of the hydrogen iodide present, so we've 0 amount of that. So guys, to figure this out, we are going to start using x, and x represents an unknown, and in this instance we're going to say that x equals the number of moles of H2 that must react in order for equilibrium to be established. So each time 1 mole of H2 reacts, 1 mole of I2 also reacts. Therefore, x is also the number of moles of I2 that reacts. From the balanced equation, if 1 mole of H2 reacts, then 2 moles of Hi must be formed. So if x moles of H2 react, 2x moles of Hi must be formed at equilibrium. So at equilibrium, we must have formed 2x moles. And we're also saying that we used up or reacted x number of hydrogen, so that figure is going to be 1 minus x. And we also use the same amount of iodine, 1 minus x. Now that we know our values for Kc, we're going to put them into the equation and see what it is. So our equation for Kc is going to look like this. Remember, our products are going to be over our reactant, so that's Hi all to be squared because it has the big 2 in front of it in the balanced equation, all over H2 and I2. And now we need to sub in our x's. So for Hi in the previous slide we had 2x, not forgetting that that's going to be squared, and on the bottom we're going to have 1 minus x all multiplied by 1 minus x. And now we need to start solving that because we know from my question that all of that is going to be equal to 50. The easiest way to solve this equation, guys, if we take the square root of both sides. So if we have a look, we have 2x squared. On the bottom we have 1 minus x, that's all to be squared, is equal to 50. So if I take the square root of both sides, I'm going to get rid of an awful lot of hassle for myself. So that ends up as, so I end up with 2x on the top. On the bottom I end up with 1 minus x equal to 7.071. I'm now going to bring my 1 minus x over to this side, so I'm left with 2x is equal to 7.071 multiplied by my 1 minus x, so I have 2x is equal to 7.071 minus 7.071x. And now it's a matter of rearranging, okay? So like we would in school, we're going to bring all our numbers to one side and we're going to bring all our letters to the other. So I end up bringing my x's to one side, so I have 7.071x plus 2x is equal to 7.071. So guys, this ends up reading as 9.071 x is equal to 7.071. So to figure out what x is equal to, we take our 7.071, divide that by 9.071, and when you roughly round out your answers, guys, we get a value of x of 0.78. Now don't forget, this question isn't over. We now need to go and put x back into our equation. So you remember our concentration of hydrogen at equilibrium was 1 minus x. So we have 1 minus 0.78, which is equal to 0.22. We have iodine, which is also the same, 1 minus x, or 1 minus 0.78, which is also equal to 0.22. And we also have HI, which is equal to 2x. So we have 0.78 multiplied by 2, so that is 1.56. So guys, I know this is a difficult one. We're going to be practicing these for a few days now. I want you to listen through to this calculation a few times and take it down in your copy. Stop the video where you need to, and I will see you in our next live lesson. Thanks so much for tuning in.